Hey, chat. Okay. Okay, my audio just stopped. Awesome. Maybe I'm maxing out my CPU. Let's... Instant scum. No. It's everything is fine. I love it when things break. Okay, awesome. Don't know why it does that. Okay, anyway. How are y'all doing? I have to actually look at, like, my knife clothes and stuff. Maybe that'll help. I don't even have that much stuff up. Oh, God. Okay, well. I guess it will be quiet forever. That's fun, right? Like, quiet time, like nap time. Oh, God. No, my G... Might just be the heat feedback loop. And that's, you know what? We'll just deal with it. It's fine. It's normal. I'm normal. So yeah, physics. I don't really know what else to say. We're doing physics with no music, apparently. Okay. Problem 9. Now, these are going to be fairly boring. Just, you know, a good... Keep your expectations low. These are not going to be like... This is not going to be glamorous. Let me make sure it's like the same kind of size, yeah. But it should be chill. Be a little funsy, silly, fun time. For some reason my chat isn't like showing up. Oh, let me also see. Am I like... Well, I don't really drop frames. It says my CPU is at 2.3. I feel like that's a lie, but whatever. Oh, it's actually calming down. Wow. Wow. My computer not having to be super loud. Crazy. Okay. Anyway, let me zoom in on my end over here. All right. In a 100-meter race, Maggie and Judy crossed the finish line in a dead heat, both taking 10.2 seconds, accelerating uniformly. Maggie took 2 seconds and Judy 3 seconds to attain max speed, which they attained for the rest of the race. What was the acceleration of each sprinter? Okay. So, got a delta x equals 100. We've got a VI equals 0 for both of them. We have a VF. We don't know for either of them. We know that t is going to equal 2 seconds and 3 seconds. And what else have we got? We know it's a constant acceleration. Okay, cool. So this is pretty much all we need. So if we get up our little equations here, we can use, so we have a time. I'm thinking we're going to do like, we don't know the final velocities, so I think we're going to use delta x, yeah. Delta x equals VOT, so that would be 0. It's 1/2 AT squared. And then for Judy, we'll do 100 meters. No, that's not actually 100 meters. Let's check that, because they took 3 seconds to attain maximum speed. So we actually don't have a delta x there. If we want to say that. So we can do... Let's see, what else can we do here? The acceleration. So we can't, yeah, let me actually write these down over here. So we've got like delta V equals AT. We've got delta X equals VI plus VF over 2T. We've got delta X equals VOT plus 1/2 AT squared. And we've got V squared minus VF squared minus VO squared equals 2ax. So we don't have a final velocity, which is not not poggers here. Maybe, oh, maybe we should like draw a little picture. Maybe that would be good. Maybe we should draw some graphs. So we know that like for this first part, they're going to be accelerating. So like they're gaining velocity, and then it's going to be like a what are they called? Not a partial. You know what I mean. The things where they've got parts of the equations. And then our velocity is going to look like a straight line and then some, point where it's off. And then our acceleration will be a, t, it'll be some number, and then dot, 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 and then 0. I should probably try and at least attempt to make it at the same t. T, and then boop, and then down here. Okay. So we want to figure out what this value is, and we know that we know that the whole time it took was 10.2 seconds. So this entire time, like this here, was 10.2. So maybe we find their final velocity. I think maybe we should do that. Can we do that? Let's see. What have we got? We could do this. This is what we could do. So if we find, like, they're both going to have this the same. What does a dead heat mean? I don't know sports terms. I assume that means they crossed at the same time. Okay, that's a horror film. Performances are judged to be so close that no difference between them. Okay. So they're gonna have this like same velocity probably at the same. Oh no, I guess they don't have the same speeds. So maybe that's not gonna help us out here. Let's see, we don't know. We don't know what the delta x is for that 2 seconds. We only know that it took 2 seconds. It's not very helpful, sadly. So what can we even get out of this? We don't know what this is. We don't know what this is. We don't know what this is. Is there anything? This seems like the right thing, but this will tell us like acceleration over a period of time, which is not gonna be right because they stopped accelerating at t equals 2 and t equals 3 respectively. So they both have the same full time. They both have the same full distance. They both have different speeds. We might have to set stuff equal to each other? Question mark? But that doesn't make any sense really either, because we would need to set, like, it wouldn't be the same for that. Let's see, delta v equals at. We can't do that unless we have acceleration. We definitely don't have acceleration. Delta x equals v initial plus v final over t. This seems like a good thing, right, to find this, but we don't wait, we actually could do this for both of them, but then their final velocities would be the same, and it seems like they're not. Then they shouldn't be. Unless... And then for this one, again, we don't know acceleration, so we have to use this. We have to use this one. But their final speeds aren't going to be the same. So like, okay, let's see. It would look something like this if this was the racetrack. They both start from 0. We'll just say this is like m. I don't even need to do anything. At t equals 2, we'll say this is like t equals 10. T equals. Here, their acceleration is going to be something. And then here, they have an acceleration. And then past this point, they finish at the same time. So this person's maximum speed is going to have to be greater. So v greater than jv. Should probably say like vm. Yeah, vj. Because they're covering more distance in the same amount of time. But they're not covering more distance in the same... Well, I guess we kind of can't know. Because the distance that they're constant for, the distance that they're accelerating for is 2, and the distance that they're running for is 8.2. Okay, so wait, we have a second time then. So m or t m2 equals 8.2 seconds. This is a equals 0. And then tj2 is going to equal 7.2 seconds. A equals 0. So we don't know how far they're covering in that time. So we can't figure out their acceleration just yet, nor their final velocities. There's got to be a trick. What is it? I'm like missing like one thing. I'm missing one link. Acceleration of each sprinter and what were their respective maximum speeds. Also, let me just... Okay. If we could figure out like x equals something, or this is x equals 100, right? But clearly, we don't know. Well, we know that if we were to know the velocity they got up to, then we could find the delta x within this time, because that would just be this, right? It's like if we knew v, like, I don't know, vo like 2, then we could find the delta x that this was, because then we would just say, you know, 2 of this. It would be, you know, distance equals speed times time. But we don't know that. Maybe we have to use this, but we don't have an acceleration. Wait a second. Unless, no, but we don't know what delta x, we only know what t. Right? I'm going insane. Oh, I need to plug in my computer, like, right away. 1 second. Woo. That was fun. One sec. Oh my god. Feels like I'm missing one thing here. What is it? There's one link. There's one little tiny thing that has to be different. The most famous physics, like if Einstein was a VTuber, the math is very hard. For some reason chat is broken. Actually, let me see. I think my like OBS like can't connect to Twitch. Omega lol. Also, my computer is very hot right now. It is toasty. Let me see. How toasty are we getting? How la toasty? I can't even see la toast. La toast meter. I don't know. Anyway. Oh, I can try and reconnect this. Wait, somebody, let me try and send something. Oh, hey, it works. Slay. I don't know why it didn't. Okay, what is it? What is up with this? Why do I have to like fucking like Frankenstein together to get this to work? Unless the whole thing is like, okay, VI plus VF are gonna be different and then like T is gonna be the same. Okay, let's try that. We know delta X is 100 meters. 100 meters for both of them. We know the VI is going to be 0 for both of them, so VF over 2 times time, which took them both 10.2. But then their final velocities would be the same, and it makes it sound like their final velocities are different. If their final velocities are the same, I think I could actually do this problem. I don't know how to do it otherwise. Like, what were their respective maximum speeds? That makes it sound like there's a difference. But also, what was the acceleration of each sprinter? Makes it sound like, oh, well, you can just know that this is the thing with the thing. Unless you can just say, like, this is 2%, or, like, not 2%, like, 20% of this time, but that doesn't make any sense. They're not at a constant speed. Okay, you know what? I'm just gonna skip it. Fuck it. We're gonna circle that one. The hallowed art of just saying, just walk it out. Okay. Okay, let's draw like a picture. This is about a rock. I love rocks. It's a well. It's a rock and a well. It's a pretty good well, I think, right? Maybe some bricks. A little bit of bricking. Okay. A rock is dropped from rest into a well. Okay, so V 0 equals 0. If the sound of the splash is heard 2.4 seconds later, how far below the top of the well is the surface of the water? Well, okay. We need to draw like a little diagram. So a rock is gonna drop into well. Right, like that. So T equals 2.4, A equals -9.8 meters per second squared. Love to see it. And then, yeah, I think we can just get stuff out of that, right? So how far is it? Well, we don't know that, but we do know this one. So we can say delta y equals 0 plus 1/2 times negative 9.8 times 2.4 squared. And finally, a win. Finally? I'm going to just assume they dropped it from the top of the well and not like into the well or like above the top of the well or anything. Not a very good problem in that respect, where they didn't tell us if they were going to drop it. Okay, so 9.2 times 2.4 squared. It's going to equal 28.224 meters. Does that make sense? Let's see. If the acceleration is, 9.8 per second, it should be like at least like, your velocity will be 9.8 times like, yeah, that makes sense. Just a little check there. I mean, I guess how far is it? What does it say? How far is the top of the well? How far below the top of the well? Below. Might as well just write that just in case. The speed of sound in air is, okay, speed of sound in air is 333, so VS, yeah, in A equals 336 meters per second. Pretty fast. If the travel time of the sound is neglected, what percentage error is introduced when the depth of the well is calculated? Okay, so what this is saying is like we have a buffer time. So we need to figure out how far it has to travel. So we have a v and we have a delta y equals, 28.224 meters. And we need to find a delta x, which is going to be, let's see, what will be good for this? We don't have an acceleration because it's a constant. So I'm guessing this. Yeah, so delta x, or yeah, delta y equals vt. So delta y equals vt, which is going to be 28.224 meters over 336 meters per second equals t equals, and we'll see what that is. Pull it out of my history. 28.224 divided by 336. That is 0.084 meters. 0.84 meters, like, right? So plus or minus on our thing, but now we have to find like how to find percent error. Right, so it would be minus. So in this case, it would be 28.224 minus 0.084 meters. So this, oops, delete, 24 minus 0.008, nope, 0.084 equals 28.14 meters. So now we'd have to calculate a little percent error, which I always forget how to do. Approximate minus exact over exact. So it's a 28.224 minus 28.14 over 28.14 times 100. So this should be, right, 0.08. But we can just kind of (28.224 minus 28.14, 0.084 divided by 28.14 times 100 equals 0.2. That'd be basically 0.3% error. 0.2985 equals, roughly equals 0.3% error. Not too bad, but, a little bit. Ooh. Cool. Let's see. What is the next? Acceleration of a marble in a certain fluid is proportional to the speed of the marble squared. Oh, cute. This is 11, I think. Yes. So A equals -3v squared. The marble enters this fluid with a speed of 1. So VO equals 1.5 meters per second. How long will it take before the marble speed? Okay, VF equals 1.5 divided by 2. Half its initial value. T equals question mark. So we have to do a little differentiation here. So A equals -3. So we want to, how do we want to do this? I think it's like A dV equals, wait, let me check that. We did it. Nope, that's the cool one. That's math. Here we go. The way we do this. Oh, yeah, I lied. So A equals dV dt equals dV dt. Let's just rewrite this as this. So dV dt equals -3v squared. We do dV times 1 over -3v squared equals dt. Then we integrate. This will be wait, let me see if that's right. I think that's right. I don't know where I wrote this. There's so much non-important stuff in my notes that it's hard to find the important stuff. No, that was proofs. Yeah. This one, I think. What's up? What's up, Umbra? Where we going? Let me see. Let me see. Can you do the math of why all my teammates are bad? For what team? Oh, like in like a video game? A video game? I could do that. Yeah. Apex. I think that the simple answer is a skill issue. On their end. Oh god, we gotta do like a little funny little, it's not a logarithm. I'd rather write it like this. Right? And then we get -3 over -2 times e to the -1 dv. Oops, not dv, plus c equals t plus c. Well, the c's don't really matter. We'll just do Yeah, it's fine. Have it over there. These negatives go away. So it'll be 3 over 2v plus c equals t. So now we know that where's our little initial condition here? We know that time t equals 0, v equals 1.5. So we'll just pop that over there. Let's solve for v real quick first, though. So let me move this. Think. Okay. So we got... how do I want to do this? We'll move the c over to the t side, actually. Because then we can just say, you know, 2v over 3 equals 1 over t plus c. And then you get v equals, you know, 3 over 2t plus c. That's a little easier. So if t equals 0, and v needs to be 1.5, v equal 1.5, or 3 halves, equals 3 over c, c equals 2. So then our rewritten equation is v equals 3 over 2t plus 2. You remove change game, how will I be funny now? I can put it back on, just for you. Just for you. I wish I could. No, it's because people kept coming in here and actually asking me to change the game. Like they were, it was like, I was like, damn, guys, come on, be funny about it. Maybe you weren't here for that. Yeah, there was people who kept asking me to. Fair reason to remove. Yeah. I literally had it like, I said only for idle games, but like somebody would come in and they would suggest something. I'm like, no, I'm not doing that. Read. Maybe use like your brain. Okay, we need 0.7 equals 3 over 2t plus 2. Then we have, oh boy, 1.4t plus 1.4 equals 3 equals what is 3 minus 1.4? That's 2, 1.6 ish. Okay, does this make any sense? Let's see. Sometimes things are serendipitous. Sometimes things are not. Let's see, 1.6 divided by 1.4. 1 and 1/7. 1.142 seconds. 143. Does that make any sense? Let's see. A is... Well, I guess we could just do the derivative of, like, this function and see if it's right. Except that it's the derivative of, like, it's like a differential equation. I don't know if I want to do that right now. I'm gonna just mark it and we'll come back to it, and you know what? Maybe it'll be right, maybe it'll be wrong. That's why we have a red pen. Let me make a better start. There we go. Oh, that wasn't good over yet. Beautiful. Beautiful little guy. Alright. Alrighty doity. What's next? Oh, this is the last problem! Well, and then I have to, like, go back and fix stuff. But, like, oh my god, this is so much faster than the other one. Hell yeah. Hell yeah, now I'm, like, excited again. Okay. Speed of a bullet as it travels down the barrel of a rifle toward the opening. It's given by the expression v equals... Oh boy. -5 times 10 to the 7th t squared plus 3 times 10 to the 5th t, where v is the velocity of the acceleration of the bullet just as it leaves the barrel is 0. Determine the acceleration and position of the bullet as a function of time when the bullet is in the barrel. Okay. So let's do the easy one first. Let's do A, because that's just a funky little derivative. So is it gonna be negative 10 times 10 to the 7th t plus 3 times 10 to the 5th? It's as simple as that. I love easy derivatives. This is just negative 10 to the 8th, actually. Look at that. Beautiful. Beautiful. Stunning. I love it when things are easy. Now, dx dt is going to be a little bit on sleigh, but we'll work with it. Then there's 10 to the 5th t. So to do this, we just need to multiply this over here. dt, right? Because we can basically treat derivatives as fractions. Who cares? We are our own gods and masters. X equals, we're going to do a funky little negative 5 times 10 to the 7th over 2 t cubed plus 3 times 10 to the 5th over 2. Wait, that's a 3. T squared plus c. I'm going to assume that our at 0, our x is going to be 0. So I'm going to just say like x at 0 equals 0, c equals 0. So our a is going to equal negative 10 to the 8th t plus 3 times 10 to the 5th. And our x is going to equal negative 10. I could make that a little nicer, but I won't. Negative 5/3 times 10 to the 7th t cubed plus 3 halves times 10 to the 5th t squared. Perfect. Although, I don't know if that's right. It seems right, though. Determine the length of the time. Determine the length of time the bullet is accelerated. Okay. So we want to find when a equals 0. Because that's when it stops being accelerated, and then we can find the time. So just gonna do a little factor. A equals 0 equals, well, actually we don't even need to do basically anything. This is negative 3 times 10 to the 5th over negative 10 to the 8th equals a, or equals t, sorry. That was a pretty good t that I wrote there. That was a pretty good t. All right, we did that. Beautiful, stunning, stellar. Now get rid of the negatives. T equals 3 times 10 to the negative 3rd seconds. That kind of makes sense. Kind of makes sense. We can Desmos it out. In fact, should I Desmos it out? Why don't we? We'll do Desmos, but we'll... Yeah, I guess I could put in the big numbers. Okay, so our V is going to be... Here, you guys can see all the Desmos. That's a treat. I don't know why I cropped it like that. There we go. So what is our V? Our V is negative 5 times 10 to the 7th x squared plus 3 times 10 to the 5th x. And let me like kind of zoom in on this. I forget how to do that. How do I do that? How do I zoom in on you? How do I zoom in on you? It's a way to do it. God damn it. Let me in. Let me in. No, not that. How did I... There's like a little magnifying glass sometimes. Oh, maybe if it's like kind of not... If there's multiple equations. Anyway, we just gotta see then if we say negative 10... Oops. Negative 10 to the 8th x plus 3 times 10 to the 5th Do I just have to like maybe double click it? Nope. How to zoom to function Desmos. No, there's like a house? No, that's default. I don't want that. Zoom to one graph. The wrench. Zoom fit? Oh, I can use a table. I can only do it for a table? What? Huh? That's sad. Why can't I only do it for a table? Oh man. Oh, I guess because it doesn't really, yeah, that doesn't make sense. I guess we gotta adjust the settings manually, chat. I don't know, 10 to the 7th. The 7th times 10 to the 7th. 5, 10 to the 7th. Oh no, 5 times 10. And then like, also 10 to the 7th. That was like 5. Where is it? Bro, where is it? Why is it so much bigger still? Hello? Hello? What the heck? What is happening? Hello? What? How much do I need to scroll out of here? Ah? Ah? Okay, we're gonna get rid of the 10s. This is gonna be 1. Although I will keep this at like 10 to like the -2. Why is this one like not chilling? What is up with this? Hello? Oh, it's a parabola. Okay, never mind. Yeah, so we have a little parabola, that's right. And then if we just say like dx of this, oh, I gotta do ddx on the other side. ddx. Oh, that's not right. Wait, what? What was I doing? Oh, because it's not that. It's like 10? Yeah, there we go. There we Lego. Buggers. Buggers, buggers, buggers. Sounds right, and then I don't really feel like integrating the other one, so we're not gonna do that one. This on, put that off. Okay, then I guess we're just gonna like... Oh, I guess I can look at just like where does t equal 0? Yeah, 0.03. That lines up with our -3rd. Like, or 3 times something, 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 something. You know how it is. I still don't know why my... Yeah, it's fine. Determine the, oh, the length of the barrel. Whoopsies. The length, no, the length of the time. Length of the time. Find the speed at which the bullet leaves the barrel. Okay, VF equals something. VF equals something. That's really easy. We just have to like plug this in. So V equals -5 times 10 to the 7th times, you know, t squared. So 3 times 10 to the -3rd squared plus 3 times 10 to the 5th times 3 times 10 to the -3rd. This sucks, but so -15. Nope, I lied. Not -15. This will be 9. I'm just gonna like 9 times 10 to the -6 for me. So -45 times 10 plus 9 times 10 squared equals 450 plus 900 equals 450 meters per second. That seems like a lot. How much is that? That's a Google search I might not want to make. How fast does a bullet leave a rifle? Like, just generally. No, I want to know. I have to, like, just tell me, like... Whoa. 307... Wait, 120 to 370? Oh, bro, that... Okay, this number seems a little big. Is that a little bit big? Well, it's probably kind of close, if not right. It should be. Well, I mean, I can also just, wait, I have the V graph. I can just plug in. Oh no, I changed it. Okay, god damn it. It's like, tell me what it is if x equals, what? Oh, I can change these to t's, and then it'll actually give me a thing. Oh god, I hate you, Windows. Get out of here. There we go. T. Yes, add a slider T. If t is equal to, what do we say? 3 times 10 to the negative 3 times 10 to the negative third. 450. Unless our t is wrong. Which, it could totally be wrong. But, you know, what if it wasn't, right? Yeah, what a funny little moment. What if it wasn't wrong? What if it was just right? I'm trying to see if there's any space that I have left to do D. I'm gonna put D right here. And then I think we're just gonna do a little wrap up. A little silly little wrap up. Wait, let me just check this one thing. Coolio. Okay. Check this other one thing. Cute. Okay. And I know it's a little shorter, but I do have to not be streaming when the fire drill starts. So, you know, delta x equals question mark. So the way we could do this is, just plug in when t equals this. So negative 5, 3 times 10 to the 7th. Oh boy, this is going to be a massive number. 3 times 10 to the 5th times 3 times 10 to the negative third cubed. Okay, that's a bit cringe. Sorry. And then, yeah, it's not too bad. Delta x equals BF. We'll just put that there. Delta x is going to equal what? Let me just plug it into Desmos. Because everything is easier with Desmos, right? Oh, I gotta write a little delta x expression here. Okay, here we go. Delta x is gonna be negative 5/3 times 10 to the 7th times, or t cubed, plus 3/2 times 10 to the 5th, t squared, a little slider t. And then we want to say t 3 times 10 to the negative third, 0.9. 0.9 meters? Bro, what? Wait, that's like 3 feet? Yeah, a rifle is like 3 feet. You could have like a 3-foot rifle. That's actually kind of long for a rifle. You know, that kind of makes sense. I'm gonna go with that. And with that, we're done, chat. Well, I'm not done. I have to go fucking check this stuff, but I don't want to. Actually, no, I want to go play Splatoon because I just got it today. I hope you guys had fun. If you didn't, let me know why you didn't have fun. If you liked it, let me know you liked it. Or not. Or, I don't know, join our Discord or something. Exclamation point Discord. I still have yet to figure out how my streams are gonna feel here. And these are I feel like these are probably not the most interesting because it's not the most exotic math. It's fairly easy. And it's boring me. So, you know, but I'd rather do it on stream because at least you get stream hours in. Content. Hashtag content. I will figure out why my music just stopped. I don't like streaming without music. It feels strange and bad. Hopefully my mic sounds okay. I didn't really check, so if it sounds bad this whole time, then, you know, I'll be better next time. At least it stopped cracking. It did stop cracking. I was very happy about that. I got a new USB hub, and it is much cleaner on my desk, and everything is beautiful. I will probably stream Saturday? Yeah, I think Saturday. And I think we'll do some math, polar coordinate areas, lengths. My professor is actually like a god at math. He is so cool. He's so awesome about teaching stuff. So it actually made me like polar, which is an incredible feat in my eyes. But yeah, I'll be back then. Hope everybody has an awesome day. And, you know, if I don't see you for a bit, then I hope you have an awesome like weekend and all that stuff. So bye everybody. It was super fun hanging out. Love you all. Au revoir. Goodbye.